The laws of indices. There are 3 of them, so let's figure out together how to form them. We've got this problem of n cubed times n to the power of 5 equals n to the power of what? We want to simplify it, but we don't know how to yet. Let's break this down a little. We've got n cubed here, which is n times n times n. And this is all being multiplied by this n to the power of 5 here, which is n times n times n times n times n. And that all equals n to the power of something. Well, this is written in a way now where we can just simplify this. So we have got 1, 2, 3, 4, 5, 6, 7, 8. 8 n's being multiplied by each other, so this simplifies to n to the power of 8. So now we've got an answer of n to the power of 8. How do we figure out how to link 3, 5 and 8 together? Well, we've got 3, 5 and 8. 3 and 5 have to do something together to make 8, while 3 add 5 equals 8. So therefore, from this we can deduce that n, or a number to the power of a, another number, multiplied by n to the power of b, another number, equals n to the power of a plus b. And there's our first law of indices. Next we've got n to the power 6 divided by n squared. So we need to figure out what this simplifies to. Well, again, if we expand this out, we'll have at the top n times n times n times n times n times n, n to the power of 6 all over n squared, which is n times n. Now, as you know, n divided by n equals 1. We've got everything on the top row being multiplied by each other and everything on the bottom row being multiplied by each other. So if we've got n and we're dividing by n, they actually cancel out because n divided by n equals 1. And again, we've got n and another n, so n divided by n equals 1 again, so they cancel out to 1. So we're left with n to the power of 4. Now, to give some numerical examples, if I said, for instance, 3 times 3 times 3, which is 27, and then we divide it by 3, so we'll have 27 divided by 3 equals 9. Well, actually, 3 times 3 equals 9. So really, this times by 3 and divided by 3 have just cancelled out, because it's the same as times in by 1. So what we can say is n to the power 6 divided by n to the power of 2. Well, if we've had n times n times n times n times n times n, and then you divide in by n, that cancels out 1, and you divide in by another n, that cancels out another 1. So we're left with just 4 of these n's being multiplied by each other, which is n to the power of 4. So we know now that our final answer for n to the power 6 over n squared actually equals n to the power of 4. So we now need to link 6, 2 and 4 together. So 6 with something happening to it with the 2 equals 4. Well, 6 take away 2 equals 4, so we can use this information for our law of indices. Therefore, the law of indices must be n to the power of a divided by n to the power of b equals n to the power of a minus b. And last but not least, we've got this one here, n cubed all to the power of 4. Now what this means is, if I write it out in full, is n times 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 n. So what we've got is n cubed here being multiplied by itself 4 times. Now this looks the same without the brackets. So this actually looks the same as a normal simplifying question. This all equals n to the power of 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, n to the power of 12. Now we've got 3 and we've got 4, and we do something with them to get 12. Well, 3 times 4 equals 12, and that actually works. So our final law is n to the power of a all to the power of b equals n to the power of a times b. So here we are, the 3 laws of indices we've generated. In the next video, we will show you how to use them. So check out the next video, like this video if it helped you, subscribe to the channel to get more notifications, and I'll see you in the next video.